The pigeonhole principle is another sort of counting idea, but it's less of counting the number of ways to do things, more so in what's the worst case scenario if I want to make sure that something happens. So when you think about the pigeonhole principle, I want you to think about the worst case scenario. What could be like the worst thing that happens until I get what I want? And so what the pigeonhole principle says is that if n items are put into m containers where n is greater than m, then at least one container must have more than one item. So we can sort of think about it with this picture here. So in the first one, the number of pigeons, 4, is less than the number of boxes, 5. So each pigeon can have its own hole. So in this case, think of the items as the pigeons and the boxes as the holes. So in this case, the items, n, is less than the holes, m. In the second case, there are 5 pigeons, 5 holes. If they want to, every pigeon could go in its own hole. That's not to say that it's going to happen, but in the worst case, every pigeon could go in its own hole. So the items is equal to the pigeons. In this last case, if you notice, the number of pigeons is bigger than the number of holes. So no matter what we do, once that 5th pigeon shows up and there are only 4 holes, he's got to be a friend with somebody else. That doesn't mean that all the pigeons won't go in the same hole, right? It could be that all 5 pigeons go in the same hole and the other 4 holes are empty. But all this says is that if the number of items is bigger than the number of holes, then at least one container will have more than one item in it. So how do we apply this? So how many cards must be selected from a standard deck of 52 cards to guarantee that at least 3 cards of the same suit are chosen? So remember, we're thinking worst case. So think about what you know about a deck of cards. If you don't know about a deck of cards, go ahead and look at a picture of a deck of cards. There are 4 suits, and there are 13 cards of each suit. So this says how many cards must be selected from a standard deck to guarantee that at least 3 cards of the same suit is chosen. Well, what would be the worst case? The worst case would be I get 1 card of each suit. So 1 heart, 1 spade, 1 club, 1 diamond. And then on my second try, I get a second heart, a second spade, a second club, and a second diamond. Now on the 9th card that I pick, I have to get 3 of 1 suit. This is worst case. Now, I'm not saying which suit I'm going to get, right? I'm just showing you that I had 4 holes, these suits, and how many pigeons do I need to fill 3 in at least 1 hole? So on the 9th pigeon showing up, or the 9th card I pick, then I'm guaranteed that there will be 3 of the same suit. It could happen earlier, right? The first 3 cards you pick could all be of the same suit. But again, when you're thinking about the pigeonhole principle, you want to think about what's the worst thing that could happen. So remember, in this example, we don't know which suit it is, right? You might draw that 9th card and you get a club. So if you draw 9 cards, you know you'll get 3 of 1 suit, but you don't know in particular which suit it is. So how many must be selected to guarantee that at least 3 hearts are selected? So remember, you're thinking about worst case. If you want to make sure that you get 3 hearts, what could happen? Well, the worst case is you pick all 13 diamonds. And then you pick all 13 clubs. And then you pick all 13 spades. And now, this is in the worst case, right? This might not be what happens. But now the next 3 cards will be hearts. They have to be. There's no other choice, right? So in this case, you picked 39 cards. The next 3 are hearts. So you have to pick 42 cards to guarantee you have at least 3 hearts. That's not to say it's not going to happen earlier, right? It might happen that the first 3 cards you pick are hearts. But to ensure, like you're picking in the dark and you want to make sure that you handed somebody over 3 hearts, the worst thing could be is that you pick all the diamonds, all the clubs, and all the spades, 39 cards, and on the next 3, you get 3 hearts.